Alright, this lesson is through square roots. Okay, so first thing that we need to just quickly review are what perfect squares are. So perfect squares are if I took the number 1 and I squared it. That means 1 times 1, which is 1. Okay, that will make a perfect 1 by 1 square. Okay, my next perfect square that I could make out of these little squares, I would need actually 4 of them to make it be a square. Okay, so that one is actually 2 squared, which is 2 times 2, which equals 4. So this actually has an area of 4. That's my next perfect square. My next one, I would need 9 of these little squares to make a square. Okay, that would be 3 by 3, and the area is 9. So my next perfect square is 3 squared, which is 3 times 3, which equals 9. Okay, so I'm going to make a list of my perfect squares. You should make this list too. My first one is 1, okay? 1 times 1 is 1. My next one is 4. 2 times 2 is 4. My next one is 9. 3 times 3 is 9. 4 times 4 is 16. 5 times 5, 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. I can keep going. 9 times 9, 81. And 10 times 10 is 100. I can keep going. 11 times 11, 121. 12 times 12, 144. I can keep listing tons and tons of perfect squares. Okay, it's all it is when I square a nice number. So I squared 1, I squared 2, squared 3. These are called perfect squares. We're going to be using those. Okay, so these are called perfect squares. Okay, so now I'm going to actually draw you a square. Okay, so I'm going to make sure I know it's a square by putting these tick marks in each side so I can show it's a square. Okay, and I'm going to tell you that the area is 49. Okay, I want to know if I can figure out what the side lengths are. Okay, so I know when I find the area of a square, I take the base times the height. So I know that something times something equals 49. And if this is a square, I know that these have to be the same number. So I think to myself, well, what times what is 49? Well, I know that one. I gave a kind of a pretty easy one. I know that 7 times 7 is 49. All right, now what I just did is I actually just found the square root of 49. Okay, it's like you're unsquaring a number. So I think, well, what times itself is 49? The answer to that is 7. So the square root of 49 is actually 7. Okay, let's try another one of those. Okay, if I have a square here again, and this time I tell you the area is 81. Okay, it's a square still. So I want to think to myself, what times what is 81? And that is actually taking the square root of 81. It's like square root is kind of like unsquaring a number. So what times what is 81? I know that is 9. Okay, now there's actually another answer besides just 9 to the square root of 81. Okay, can you think of another number times itself that actually equals 81 besides 9? Okay, the other number is actually negative 9. Because if I work that out, negative 9 times negative 9 is actually 81. Okay, I can show this instead of writing 9 comma negative 9. I can show it like this. I can write plus or minus 9. That means the positive 9 and the negative 9. So you can write it like that. Okay, so if I give you a few problems, if I ask you the square root of 25, the square root of 100, okay, you should be able to do those too. Think to yourself what you think the answers are. All right, the square root of 25 is actually 5 or negative 5, so you guys can write that as plus or minus 5. The square root of 100, what times what is 100? Well, that's 10 or negative 10, so I could write it like this. Okay, now most commonly, you're only going to have to give the positive answer. If you want the negative answer, here's what kind of problem I would give you. I would write it like this. Okay, the negative square root of 9. That means I would want you to tell me what's the square root of 9. Well, 3 times 3 is 9, and then I want the negative answer. Okay, now if I want both answers, I'm going to give you a problem like this. Plus or minus the square root of 25. So that means I want the positive and the negative answer. So the square root of 25 is 5, and then I want the positive and the negative answer. Okay, so that's kind of how you'll see your problems. All right, another type of problem that you're going to see is the square root of fractions. So I'll kind of give you one. You might see one like this, the square root of 36 over 64. Okay, to do the square root of fraction, it's not too bad. All you actually do is you do the square root of the top and the square root of the bottom. Okay, so if I think, what's the square root of 36? What times what is 36? Well, that would be 6. Okay, on the bottom, what's the square root of 64? What times what is 64? And it would be 8. So my answer, the square root of 36 over 64, is 6/8. Now, I can actually check that by actually multiplying. Let's see what 6/8 times 6/8 is. Well, 6 times 6 is 36, and 8 times 8 is 64. And that's what I had over here, so I know I did it correctly. Okay, so that's how I do the square root of fractions. Okay, one more type of problem that I'm going to kind of show you. You might see something like this. Okay, now this means I have 2 times the square root of 25. You always should do your square roots right away. Okay, so the square root of 25 is actually 5, and now it says times 2 out front. So 2 times 5 is 10. So that's how I would do a problem like that. Okay, now one other type of problem. You might see problems with decimals. So you might see something like this, the square root of 0.25. Okay, so you do it the same way. You want to know, well, what times itself is 0.25? Well, kind of think, just think of that like a 25. Well, that would be 5, so my answer is actually 0.5. Because 0.5 times 0.5 is 25. Okay, one other thing that you're going to have to be doing is estimating with square roots. Okay, so estimating with square roots. Now, here's how you would do that. So let's say I ask you what the square root of 7 is. Okay, now that is not a perfect square. That is not a nice one that you know. So here's how you estimate. Okay, you want to try to think of that list of perfect squares. What's a nice one that you know that's right above 7 and right below 7? So what's one of those perfect squares? So again, here's my perfect squares. 1, 4, 9, 16, 25, 36, 49. Those are my nice perfect squares. So I want to pick the ones that are close to 7, right above it, and right below it. Well, 9 is right above 7, and 4 is kind of below it, pretty close. Okay, so now here's what you do. You want to figure out, well, I know the square root of 4, which is 2. I know the square root of 9 is 3. So the square root of 7 has to be between 2 and 3. But I want to kind of make a little bit better estimate. Okay, I want to see, well, is 7 closer to 9 or to 4? No, it's only 2 spots away here, 3 spots away here. So it looks like it's a little closer to the square root of 9. Okay, so I'm going to take an estimate. I think it's a little closer, so it's over halfway. So I'm going to estimate about 2.6. And I'm going to use this symbol. That means approximately or about 2.6 since I estimated. Okay, we're going to do one more. Okay, so let's say I want you to estimate the square root of 50. Okay, so to do this, you want to think of your perfect squares. Okay, and we want to find one that's right above 50 and right below. So a nice ones that I know. So if I start thinking, I know my perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81. Okay, I don't think I need to go much higher. Okay, so now the ones that are close to 50 are 49 is right below it, and 64 is a little bit above it. Okay, so I'm going to think, well, what's the square root of 49? Well, 7 times 7 is 49. And what's the square root of 64? Well, 8 times 8 is 64. Okay, so my answer has to be somewhere between 7 and 8. Okay, it's going to be somewhere between there. Now, 50 is very close to 49. It's only 1 away. It's 14 away from 64. So my answer is going to be a lot closer to 7 than 8. So if I was going to estimate, I would guess about 7.1 or 7.2. That would be my estimate. All right, so that covers square roots. If you have any other questions, make sure you see me. All right, so those are square roots.